Hi guys, day 2 of review, and just to do something a little different today, I thought we'd do flashcards with Opel, okay? So I made some flashcards just to be fun. I know I could do it on the Smart Notebook, but I thought, hey, let's change it up. Things are a little different right now, and let's just do it this way. So I want you to join me. I'm going to go through some things and see how well you do it, and I want you just to do this over and over to help practice for that AP exam. I miss you guys a lot, and I hope all is well. What I will say is at the end of this video, I'm going to give some hints for your homework today. So stay, you can pause at that point or come back or whatever. So here we go. First one, so I'm going to show you the word, and then I want you to say it out loud. I'll give you some time to think about it, to say it out loud, and then I'll show you what I was looking for. And yeah, there's different variations of what the AP will accept. So if you have any questions, pause, and then write your question down and then submit it then on our discussion section of Schoology. Okay, ready? Here we go. First word I want you to think about is, how do you interpret the mean? I'll give you a second to say it out loud. And here is what I was looking for. In the long run, you can expect, then you put context. Oh, I'm wrong. You could expect the average, blah, 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 to be about blank, okay? So in the long run, you can expect on Mrs. Opel's test scores, the average test score would be about 85%, okay? Something to that effect. But I'm looking for the word expect, average, and about in the long run as well, because all probabilities or means, averages are in the long run. The next word we have is standard deviation. This is a huge one. You do have, well, all of these are big, but this one I have seen. Interpret the standard deviation. So I'll give you a minute. Okay, here we go. The average distance observations are from the mean. So we would say if the standard deviation was 10 for test scores, we'd say, well, 10 is the average distance test scores are from the mean in Mrs. Opel's classroom. Okay, the average distance observations are from the mean. And I'm thinking of this context off the top of my head. So if that's not working for you and you want me to give you a specific example, that's totally fine. Just write that down on that Schoology discussion section. IQR, interpreting the IQR. If you've forgotten how to find the IQR, think of it right now. It's quartile 3 minus quartile 1. The spread of the middle 50% of the data is your IQR. So if the IQR in my test was 10, you'd say that's the spread of the middle 50% of Mrs. Opel's test scores. The median, quartile 1 and quartile 3. Again, this is interpreting them. Think about it, write it down, say it out loud. %50 of the observations are less than or equal to that score or whatever the context is. Now I underlined 50%, right? This is weird because everything's backwards. 50%, you would change that to 25% if it was quartile 1 you were interpreting, and 75% if it was quartile 3. Next flashcard. A Z-score. I've seen this one for sure on free response as well. What is a Z-score? A Z-score is a measure of how unusual something is, okay? If there is a Z-score that is above 2.5 or below negative 2.5, some people use 2 and negative 2 as well. That is considered an unusual score. But the exact interpretation of a Z-score that the College Board is looking for is the exact standard deviations and observation. Oh no, I'm running low on battery. Hopefully I'm still going. Am I still going? I'm frozen. I was worried there for a second because my computer showed low battery. Okay, so anyways, Z-score, the exact standard deviation and observation is from the mean. And I think that's all no, I don't, I have more. Outliers, do you have the outlier rule memorized? I'll give you a second to say it out loud. Write it down, that helps as well. Your upper fence is quartile 3 plus 1.5 times the IQR. Your lower fence is quartile 1 minus 1.5 times the IQR. If there's any data that is greater than the upper fence, that's considered an outlier. If there's any data that's less than the lower fence, that's considered an outlier. Okay. Next flashcard. If your mean is approximately equal to the median, what does the shape of the distribution look like? Give you a second. It is symmetric. Way to go. If the mean is less than the median, what is the shape? I put it on there. Spoiler alert. Skewed left. If the mean is greater than the median, what is the shape of the distribution? The shape is skewed right. I hope you took some time. It's only 6 minutes to go through flashcards with Opel, and I'll have another edition for you in a couple days. Play this over and over until you have 100% down. You got it. You're good. So this is flashcards edition number 1. Okay. And what I'm going to do right now is I'm going to instruct you to pause this video, and I want you to go to Unit 1, Day 2 review. There's 2 free response questions. Take some time to do that. Write down any questions that you might have, and then come back to the 6-minute mark. Okay. And then I have some hints for you right now. So pause it, try that, and then we'll see you back here in a second. Okay, guys, here's your hints for today if you're struggling at all. For this gasoline example, it's asking about how transformations affect data. So I just give you a little example here. If we had 1, 2, 3, 4, and 5 for data here, excuse me there. Let's say they're test scores or whatever, and I wanted to curve it, okay? If I wanted to add 10 to each data, how would that affect our mean, our median, our standard deviation, and our IQR, okay? So I add 10 to everything. What would happen is I would take 1, 2, 3, 4, 5, and I'd add them up 10 places. So everything would change but the spread, because the spread is talking about really the variation between observations, right? And so when I take 1, 2, 3, 4, 5, and I just add 10 to it, everything changes but that actual like space between each observation, that variation there. Okay, so adding or subtracting data, right, the other way around, that's really only, like, it's not affecting the spread. It affects everything else. So the mean would go up by 10, the median would go up by 10, right? But the range would remain the same, okay? The standard deviation would remain the same. The IQR would remain the same. Each individual location, 1 would go up to 10, 2, so on and so forth. 2 to 12, so on and so forth, okay? Hopefully that makes sense. I screwed that up. One would go up to 11, 2 to 12, so on and so forth. Sorry, forgive me. Okay, I'm not going to start over now because I'm 8 minutes in. No big deal. All right, the next one, the next example. Let's rewind, actually. Let's talk about multiplication. If I would take 1, 2, 3, 4, and 5, and I multiply everything by 2, then everything changes, right? Because now multiplying 1 by 2 is 2, 2 by 2 is 4. So the space between them changes too. 3 times 2 is 6. That space, that spread changes as well. So the standard deviation would be multiplied by 2. The IQR would be multiplied by 2. The range would be multiplied by 2 as well. Again, if you need something more specific, if that didn't make sense, these videos are not meant to like reteach it to you. It's just meant to remind you. And I'll gladly make a small, like a shorter video on just one thing, one topic to reteach you if that's what you need. Okay, whatever you guys need, you just need to let me know. Okay, the next example is that golf balls example. Okay, and I think it's talking about how far you can hit and drive a ball or whatever. Doesn't matter. That first part is you're finding a z-score, okay? And then you're going to the chart and finding the probability. And I know some of you know how to use the normal CDF because Mr. Jans taught you that, and that's totally fine. You just do what you need to do to figure out the right answer. The second one is what AP likes to do is they like to throw in some like different units tied in with other units. So they're all not just necessarily separate. That second one is taking that probability from step one, and then you have to actually use that binomial model, okay? And the thing with binomial probabilities is you just have to remember there's a fixed number of observations. And I think the fixed number of observations is 5, okay? So that's your NPK. Try it on your own. If you need more help with that, let me know, but it's either a binomial PDF or a binomial CDF. A binomial PDF would be if it's exactly 5. A binomial CDF if it is a less than or equal to. And if it's a greater than, we have to do something as well. And I'll do a whole video on the binomial geometric distribution later in our review. And finally, that number 3 is that Z in reverse. So that's where you go to that table, and some of you know how to use that calculator as well. And you go and you see what percentile they're looking for. You find the Z-score that goes with it, and then you plug everything into the Z-score that you know. You're going to know the Z-score, you're going to know the mean, you're going to know the standard deviation. You are not going to know the observation, so you need to use algebra to solve for that observation. Again, let me know if you have any questions. All right, guys, I am done for the day. I appreciate your willingness to learn online and do this distant learning thing. You guys have a positive attitude, and we will all strive for a 5 and get there, you guys. Take care. Where is the stop button? Where is the stop button? I'm still here. Oh, right here. Got it.